Hello friends, this is Priyanka. Today we are going to solve a problem on given mechanism. In this video, we are going to draw space diagram, velocity diagram and acceleration diagram with some suitable scale. First, I will read what is the given problem. Find out the acceleration of the slider D and the angular acceleration of link CD for the engine mechanism shown in diagram. The crank OA rotates uniformly at 180 rpm in clockwise direction. The various lengths are OA 150 mm, AB 450 mm, PB 240 mm, BC 210 mm and CD is equal to 660 mm. So this was the given question. Let us first draw the space diagram with some suitable scale. Now if we observe the dimensions, we will consider here the scale 1:1/3. Now if we observe the fixed points, so here there are two fixed points, point O and point P. So the horizontal distance and vertical distance in between these two fixed points is given, and we have to first plot these two fixed points with reference to each other. Now first we will take one particular point, that is for the point O, and that is the fixed point. Now with reference to the point O, the horizontal distance is given 150 mm. So as per the scale 1:1/3. So 150 mm, that means 15 cm. So 15 divided by 3, that is 5 cm horizontal distance we have to select, and then the vertical distance we have to select 420 mm, that is 42 cm, and as per the scale 42 divided by 3, that is equal to 14 cm. So vertical distance we will take 14 cm, and we will plot here the next fixed, that is the second fixed point, that is the point P. Now if we observe, the crank OA is given is at the 30-degree angle with the vertical line. So we will take here the 30-degree angle with the vertical line and having length 150 mm, that means 15 cm. So as per the scale we will divide it by 3. So 15 divided by 3, that is 5 cm, we have to draw here one line. So in this way this point A is getting fixed. Now from this point A there is the link AB, but its inclination is not given, so we have to plot the point B. So if we observe from the fixed point P, there is the link PB also. So we will consider here the fixed point P, we will take it as a center. And what is the distance PB? So distance PB is given 240 mm. So as per scale we have to take 8 mm distance, and we have to mark here one arc. In the same way, distance AB is given 450 mm. So in the compass we have to take 15 cm distance, take A as a center and mark here the arc. So the point of intersection will give us the point B, because here the point P is located and here is also point A is located. So if we join these two points, then we will get the link PB also and AB also. Now the next link BC is given. So BC is nothing but the extension of PB. So we have to just extend this link PB in this direction. And then the length of BC is given 210 mm. So as per the scale we have to select here 7 cm distance, and we have to locate here the point C. Now there is the link CD is given. So at point D there is the slider that is getting attached, and the vertical motion of the slider is given in the form of dash and dot. So here is the line, that is the dash and dot, and from this point P there is the horizontal distance is also given. So this horizontal distance is given 300 mm. That means 30 cm this distance is given. So as per the scale 30 divided by 3, that is 10 cm. We have to take this horizontal distance as a 10 cm and mark here one line, because the motion of the slider is along this vertical line. So here in the form of dash and dot. So from this point C we can take the arc. So here CD length 660 mm is given, that is 66 cm. So 66 divided by 3, that is equal to 22 centimeter, we have to take C as a center and mark here one arc. So point of intersection with this vertical line will give us the point D. So in this way, this space diagram as per the scale is getting completed. Now we will move for the next. That is the rotational speed of A with respect to O is given, that is NAO, 180 rpm. So omega, that is angular velocity, 2 pi n by 60. So n is 180 rpm. So 2 pi into 180 divided by 60, which is equal to 18.85 rad per second. And then velocity of A with respect to O, that is VA, is given, that is linear velocity. How to calculate? So we know that angular velocity multiplied by the length of the crank OA. So omega AO into OA. So OA we have to take into meter. So 150 millimeter is given. So meter, that is 0.15 meter. So 18.85 into 0.15, which is equal to 2.83 meter per second. So this is about the magnitude. So here is the magnitude of velocity of at point A. But what about the direction? So we know that the linear velocity is having direction perpendicular to the link. Now in which direction we have to draw the perpendicular line? So if we observe here, the motion of this crank is given in clockwise direction. So if I draw here the clockwise direction, the arrow is pointing towards left hand side. So I will draw here perpendicular line to this link OA. So I will align one edge with this link because these two edges are perpendicular to each other. So I will align one edge with this link OA, and from the other edge I will draw here one perpendicular line. So this is the perpendicular line and here is the arrow. So it will indicate us velocity at point A with respect to O. Now we will draw velocity diagram. So for that we will take the magnitude of the velocity at point A with respect to O, that is 2.83 meter per second. We will consider some suitable scale, that is 1 meter per second is equal to 5 centimeter. So what is the scale that we have to take for 2.83 meter per second? So 2.83 multiplied by 5, that is equal to 14.15 centimeter. So we know the direction, that is this is the direction of the velocity A. So in the same direction we have to draw here one vector. So for that we will first observe what are the fixed points in this diagram. So here point O and point P, 2 points are the fixed points. So we will consider here one particular point. So we will give here small o and small p. And then from the point O we will draw one vector which is parallel to the direction of this VA. And magnitude is equal to 14.15 centimeter. So it is drawn. So this is the vector O to A. So I will show arrow also in the same direction of this VA, and this vector OA represents the velocity of A. So I will show here as a VA. Now if we observe next point, that is here is the point A is getting attached to this point B, that is the link AB is there. So how to show the linear velocity of this link AB? So we know that the linear velocity is in the perpendicular direction to the link. So I will make here one construction. With this protractor I will draw one perpendicular line to the link AB. So I will align one edge to this AB, and from the other edge I will draw here one perpendicular line in the form of dash. Now we have to draw one line passing through this point A but parallel to this construction line. So on which side we have to draw this line? So currently we don't know. So I will draw this line on the both sides of A. Then next is how to locate the point P. So if we observe, this point B is again getting attached to this link PB. So again we will draw the linear velocity for this link PB. So we know that the linear velocity is always in perpendicular direction to the link. So again with the help of protractor, draw one perpendicular line to this link PB. So I will draw here in the form of dash. So for this link PB, one point is P and other point is B. So point B is unknown, but point P here we have already located. Now we have to draw the line passing through point P but parallel to this construction line. So I will draw here one parallel line but passing through this point P. So here is the point of intersection, and this point of intersection is nothing but the point B. So I will say this is the point B. Now if we observe in this A and B, initial point is A and final point is B. So I will show arrow towards B. So this vector AB indicates velocity of B with respect to A. Then here also initial point is P and final point is B. So this arrow indicates the velocity of B with respect to P. So P is the fixed point, so simply we can say VP. Then we will move for the next. So next point is C, but this C is on the line PB extended. So here is the link PB. So we will extend this link PB and the location of point C somewhere on this extended PB. So how to locate that? So for that we will consider here one ratio. So if we observe this space diagram, I will consider here PB by BC is equal to, here this PB divided by BC. Now this BC is unknown, that is where is the location of point C is unknown. So what is the value of PB? That is 240. What is the value of BC? That is 210, which is equal to, now we will put here the value of P to B. So it is approximately 10.2 centimeter. So I will write here 10.2 centimeter divided by BC. So here one unknown term is BC and we can calculate this. So here the link BC is equal to 8.925 centimeters. So we will take here the distance from B to C 8.9 centimeters and we will mark here one point. Now from the point C there is the link CD. So again we will draw here the linear velocity for this link CD. So it is in the perpendicular direction to the link CD. So here is the line perpendicular to CD. So I will take here parallel line for this construction line and I will draw one line passing through the point C. Now exact location of this point D is unknown. Now if we observe at point D there is the slider and which is having motion along the vertical line. So how to show this motion along the vertical line in the velocity diagram? So we know that we always show the reciprocating motion of the slider along the horizontal line or vertical line. We have to take this line passing through the fixed point. So here the fixed point is the point O. So I have to draw one vertical line because the motion of slider D is along the vertical line. So I will draw here one line, that is one vertical line but passing through the fixed point O. And this is the point of intersection and this point of intersection is nothing but the point D. So here I will say this is the VB. Now what this vector C to D indicates? So here the initial point is C and final point is D. So I will say velocity of D with respect to C. And here the vector O to D indicates the reciprocating motion of this slider at point D with respect to fixed point. So simply we have to say this vector indicates velocity for the slider D, that is Vd. So this is the velocity diagram. Now we will move for the calculation of velocities at different points. Now if we observe the velocity at point D, so for that we have to measure the vector O to D and which is equal to 16 centimeter. So our scale is 1 meter per second is equal to 5 centimeter. So 16 divided by 5, which is equal to 3.2 meters per second, is the velocity of this slider D. Now VDC, that is the velocity of this D with respect to C. So we have to measure the vector C to D. So it is equal to 8 centimeter. So as per the scale, 8 divided by 5, 1.6 meter per second. Now for this vector C to D, we will show here the arrow. So in this perpendicular direction there is the velocity. So I will show the arrow towards the right hand side and it will indicate VDC. Then VBA, that is the velocity of D with respect to A. So for that we have to measure the vector A to B. So this vector, that is 7 centimeter. So as per the scale, 7 divided by 5, that is 1.4 meter per second. So again I have to show arrow. So for this vector A to B, this is the direction that is perpendicular to this AB, and I will say VBA. Then VBP, that is the velocity of B with respect to P. So here is the vector P to B that we have to measure. So this length is 10 centimeters. So as per scale, 10 divided by 5, that is 2 meters per second. Now if we observe the direction, that is it is in the downward direction. So for this PB link, I will show this arrow, and this arrow will indicate VBP, that is the velocity of B with respect to P. Now from this velocity, we are going to calculate the radial component of acceleration. So we know that how to calculate the radial component of acceleration, that for any link we will take the velocity square divided by length of the link. So length of the link we have to consider in meter. And this radial component of acceleration is always parallel to the link. So first we will take radial component of acceleration for this crank OA. So for this we will take the velocity at point A, that is 2.83 square divided by length of the link, that is 0.15. So here it is 53.39 meter per second square. Now radial component of BA. So here is the link. So we have to take the, what is the velocity, that is 1.4 square divided by length of the link, that is 0.45, which is equal to 4.35 meter per second square. Then in the same way for radial component for the link PB. So for that again for this BP, 2 meter per second is the linear velocity. That means 2 square divided by length of the link, that is 0.24, which is equal to 16.66. Then radial component for this link CD. So again we have to take the velocity for this CD, that is 1.6 square divided by length of the link, that is 0.66. So here the value is 3.87 meter per second square. So these are the radial components for each link. So we have to consider these values, and with suitable scale we have to draw the acceleration diagram. For acceleration diagram we will consider here scale 1 meter per second square is equal to 1 by 3 centimeter. Now if we observe the radial component of this crank OA is getting calculated, that is 53.39 meter per second square. So as per the scale we have to divide it by 3, that is equal to 17.79 centimeter scale we have to take. So if we observe the question for this crank, the angular acceleration alpha is not given. So we will consider here, that is the crank is rotating at the constant speed, and that's why the tangential component of acceleration will become 0. So here this radial component of acceleration for this crank OA is nothing but the total acceleration. So this total acceleration I will show with the help of black marker. So we know that this radial component of acceleration we have to show with the, that is the line parallel to this crank OA. Now in which direction we have to draw the parallel line? Now we have to show the direction towards the center. So here the point A is rotating about the fixed point O. So we have to show the direction towards the point O, that is in the upward direction. So let us first take the two fixed points, that is O and P, as a O dash and P dash. and from this point we have to draw one line parallel to this link OA and in the upward direction and with scale 17.79 centimeter. So approximately I will take 17.8 centimeter. So here the initial point is O dash and final point is A dash. So this vector O dash to A dash indicates us the acceleration. So we will say total acceleration at point A. Now at point A again there is the link AB. So for this link AB there is the radial component of acceleration, that is 4.35 meter per second square. So as per this scale 4.35 divided by 3, that is 1.45 centimeter we have to take. So this radial component of acceleration I will show with the help of red marker. So again we have to take the line parallel to this link AB. But in which direction we have to draw? So here the velocity of B with respect to A, that means A is the center, so direction is towards the downward direction. So with scale 1.45 centimeter I will draw here the line passing through this point A dash. That is approximately I will take 1.5 centimeter. So here is the line, so I will draw here in the form of, so A dash to A double dash. So A dash to A double dash I will show arrow in the downward direction and this vector indicates the radial component of AB. Now we will move for the tangential component. So we know that the tangential component is perpendicular to this link AB. So I will draw one line perpendicular but passing through this point A double dash. So how this direction is selected, because here the velocity is also in the direction towards the right hand side. So I have drawn here the line towards the right hand side direction. Now the exact location of point B is unknown. So again if we observe, this point B is connected to this point P. So if we take the radial component of this PB, so here the radial component of BP is 16.66. So as per scale we have to take 5.55 centimeter distance. So we have to draw the radial component parallel to this link PB and direction is towards the fixed point, that is in this direction, that is the left hand side. So I will take the line parallel to this PB and the scale, that is 5.6 centimeter, and draw here one line, and here from P dash to I will say this is the P double dash. I will show direction also, and this indicates this vector P dash to P double dash indicates the radial component of link PB. Now again we will move for the tangential component. So tangential component is parallel to this velocity. Now this velocity is in the downward direction. So what happens if I draw the line parallel to this velocity but in the downward direction? So there is no any point of intersection, because here we have to draw the line in the upward direction. So here is the point of intersection, and this point of intersection is nothing but the point B. So I will say here is the point B dash. So this vector P double dash to B dash will indicate us the tangential component of PB, that is A raised to T PB. And here this vector A double dash to B dash indicates us the tangential component of AB, that is A raised to T AB. Now if I join this P dash and B dash and A dash and B dash, then it will give us the total acceleration. So total acceleration we will show with the help of the black marker. Now if we observe, here is the link BC. So this link BC is the extension of link PB. So where is the link PB? So if we observe P dash to B dash, this is the total acceleration. So I will extend this line and we have to locate the point C dash. somewhere on this line. So how to select that exact location of this point C? So we will take the ratio, that is PB by BC is equal to P dash B dash. So here is the P dash B dash, which is equal to divided by B dash C dash. So now we have to put the value. So this distance B dash C dash is unknown. So if all the other values are known, then we can calculate this B dash C dash. Here the distance P dash C dash is equal to 11.37 centimeter. So from this P dash select the point C dash. Now if we observe, this point C is connected to point D. So now the radial component for this link CD is known, that is 3.87 meter per second square. So as per scale we have to take 1.29 centimeter. So in which direction we have to draw this radial component? So for this link CD, if we observe, C is the center and D is moving with respect to C. So I will show here the direction in the downward direction. So take the line parallel to this link CD and draw one line passing through this point C dash. But this scale 1.29, so approximately 1.3, I will select here one point and draw one line. So from C dash to C double dash I will take this. Now we have to draw the tangential component. So we know that tangential component is in the perpendicular direction to the link. So I will take here one line parallel to this velocity line for this link CD and draw here the line passing through C double dash. So this is the tangential component, but the exact location at the point D is unknown. So how to find out the exact location? So if we observe, here is the point D is having slider and which is having reciprocating motion along this vertical line. So vertical line reciprocating motion, we have to show this in this acceleration diagram. So how to show? So we know that this reciprocating motion for the slider is with respect to the fixed point. So we have to show motion along the vertical line by drawing the vertical line passing through the fixed point. So I will draw here one line passing through the fixed point. That is, here is O dash P dash. These 2 points are the fixed points. So I will draw one line, vertical line, and here is the point of intersection. Now this point of intersection is nothing but the point D, that is, we will say D dash. So in this way, this is the tangential component. So if we join the end points for this radial component and tangential component, it will give us the total acceleration. Now we have to show this also, that is the C dash to C double dash. It will indicate us the radial component of CD, and this C double dash to D dash, it will indicate us the tangential components of CD. So in this way, this acceleration diagram is getting completed. Now we will move for the calculation part. So first question is that we have to find out the acceleration of slider D. So this slider D is having the motion along the vertical line. So with this vertical line motion is shown with respect to fixed point. So we have to measure the vector O dash to D dash. So what is its length? That is 22 centimeters. So our scale is 1 meter per second square is equal to 1 by 3 centimeter. So here for 22 centimeter, here is the question mark. So if we make here cross multiplication, that is 22 multiplied by 1, which is equal to 1 by 3 multiplied by x, where x is the unknown term. That is, x is equal to 22 multiplied by 3, that is 66 meter per second square. So answer is 66 meter per second square. Now the second question is that we have to find out the angular acceleration for this link CD. So angular acceleration, that means alpha, that we have to find out. So we know that this alpha is getting calculated with the help of the tangential component for this link. So we have to measure where is the tangential component for the link CD. So C double dash to D dash is the tangential component for the link CD. So we will, if we measure the distance between C double dash to D dash, then it is 5 centimeter. So as per this scale, we have to take 5 multiplied by 3, that is 15 meter per second square. This is the value for the tangential component. So how to calculate the alpha? So alpha for link CD is equal to tangential component of CD divided by the length of link CD. So length of link CD we have to take in meter. That is 15 divided by 0.66, which is equal to 22.72 rad per second square. So this is the answer, but now we have to decide its a direction. So if we observe in this link CD, C is the center and where is the direction of the tangential component? So direction of the tangential component is towards the left hand side. So if I take C as a center and move the compass in this direction, then this is the direction of the motion. So this motion of the direction is in the anti-clockwise direction. So we have to write the answer, that is its direction is in anti-clockwise direction about point C.